Hello, good evening. Happy Wednesday. Why is that you only alone, Jala? Okay, by the way, good evening. We are going into our chapter 8 today. Do you have this note with you? Yeah, it's only you alone today. Maybe they're late or whatever, I don't know. Right, so we're doing something easy today, luckily. Like as I said, we have 2 chapters remaining, or 3, I forgot. So we are going into something easy, right? Pressure. This is a physics chapter. Right, this is a physics chapter. Hello, Charlene. Wow, I haven't seen you in a while. How are you? And you haven't seen you in like what, 3 weeks, I guess? 3 weeks. Okay, so we just started. So guys, we are in chapter 8 today. We are in chapter 8 today. Okay, chapter 8 today. This chapter is called pressure. Okay, this chapter is called pressure. And we only have 2 parts here. I'm gonna do one part today, and next week we are gonna do the other part. All right, a very easy and short chapter. I will finish this in 2 lessons, no problem. Right, guys, shall we begin? Are you ready? Do you have your notes? Shall we ready? Are we ready? Shall we begin? Yes? No? Yes? No? Do you have your notes in front of you? Are you ready to absorb? This is quite an easy part to score if it comes out in exam, which is high probability. Right? So I begin. I begin. Charlene, Jella, can I get an okay if you are ready? Okay, cool, cool. Right, so here goes. Right, so today we are talking about this thing called Pascal's principle. Okay, Pascal's principle. Right, so what is this? Guys, let me ask you, can we compress liquid? Can we compress liquid? Can you make a 200, okay, let's say I have a cup of water, 200 ml. Can I press it to 199? No, right? No, right? So guys, liquid is incompressible. Okay, this is what I want you to put in your head. Liquid cannot be compressed. Is it mentioned here? Yeah, there, you see, liquids are incompressible. We cannot compress liquid. So when we press liquid, the liquid has to go somewhere. Okay, the liquid has to go somewhere, and the pressure is equally felt throughout the liquid. Okay, this is what Pascal said. Pascal's principle states that the transmission of pressure exerted on a fluid, liquid or gas, that means if I press a liquid in an enclosed system, is uniform throughout the liquid and in all directions. Okay, what do I mean? Okay, let's say this one. You see, liquid cannot be pressed, right? Liquid cannot be compressed, right? So when I have this thing, this container which has holes at different points, when I press this pressure here will be transmitted everywhere equally. So guys, I have a question here. The water jet spray out from A, B, C, D, E, F, G, is it the same? Is it the same? Do I get the same water jet coming out from A, B, C, D, E, F, G? Do I? Do I? Do I get any difference here? Do I get any point that has more water, any point that has less water? No, right? No, right? So when I press here, I will get water jet spray out equally. That means pressure is equal everywhere. This is what Pascal principle said, right? When you compress a liquid, pressure is equally everywhere. Let's say the pressure here is 100 PA. PA is the unit. I will get 100 PA everywhere. No matter where you are in this liquid, you will feel the same amount of pressure. You will feel the same amount of pressure. This is what Pascal principle said. All right. So you look at the definition again, you will understand. Transmission of pressure on a fluid is uniform throughout the fluid. Okay, you get the same pressure everywhere in the fluid. Okay, you guys cool? You guys okay? You guys cool? If you're cool, then I'm moving on. I'm moving on. So this thing is where we apply it into hydraulic system. Do you know what is a hydraulic system? Do you know what is a hydraulic system? Hydraulic system is when we use liquid to do work. It's when we use liquid to do work. Okay, guys, let me ask you, when I press, okay, can you see I have two pistons here? I have two pistons here. This thing can freely move up and down. This thing also can move freely up and down. Guys, question. When I press this thing down, what's going to happen to this? When I press the first piston down, what's going to happen to the second piston? Can I compress liquid? I cannot compress liquid, right? I cannot compress liquid. So when I press the liquid down, let's say I press this down for 5 cm, that 5 cm of liquid has to go somewhere. So what happens to this? What happens to this big piston? Anyone? Anyone? When I press this down 5 cm, what happens to this? This thing will raise up by 5 cm, right? Right? Are you following what I'm saying here, guys? Are you following? Are you following? Hey, guys, you guys with me? Don't so quiet, can ah? Hey, answer me lah. This thing will go down 5 cm, this thing will go up 5 cm. Does it make sense to you? Does it make sense to you? Guys? Anyone? Yes, okay, thank you. Right, so 5 cm down, 5 cm up. Because you see, liquid cannot be compressed. The liquid has to go somewhere. That means if there's a pressure here, the pressure throughout the liquid is uniform. You see, uniform pressure throughout. That is the meaning of hydraulic. That is Pascal's principle. Okay, guys. Now here comes the calculation. Here comes the calculation. I think this formula, you have seen it before already. I think you learned this in Form 2. Pressure equals to force divided by area. Pressure equals to force divided by area. Okay, let's look at this. You see, this is the force, right? This is the area. So, force divided by area, my pressure here is 5. Okay, the pressure at the first piston here is 5. That means no matter where I stand in the liquid, no matter where I stand, I will feel the pressure of 5. Do you understand? Do you understand? No matter where I stand in this liquid, I will get a pressure of 5. Okay, because when I press here 5, everywhere will be 5. This is what Pascal said. This is what Pascal said. Including here, I will get the same pressure here, which is 5. You might say, okay, sir, cool story. So what? How is this doing any work for me? Okay, you see, very easy. So I have the area here, 100, right? So what's the force here? What is the force of the load I'm lifting up? So we reverse the equation of P equals to 10 over, sorry, F over A. Pressure is 5. Force, I don't know. A is 100. So guys, what is the force? What is the force? 500. Good. Thank you. So that means I'm lifting a 500 Newton load. Okay, guys, can you see this is the magic of hydraulic? You see, both sides same pressure. 5, 5, right? But you see, small piston, 2 small piston, small force. Big piston, big force. Okay, small piston, small force. Big piston, big force. Can you see this is the beauty of it? This is the beauty of it. That means I can use a very small force to lift a very heavy object. In fact, this is 50 times heavier. I just have to push with a very light load, with a very light force. I can lift something 50 times the weight. That's the magic about hydraulic. Okay, guys, we use hydraulic everywhere. Every machines that you use to lift something heavy, that is hydraulic. You know what is this? You know what is this? You know what is this? I'm sure you have seen this before. When your dad goes to a workshop, right? When your dad goes to a workshop, the workshop needs to put the car up so that he can check underneath. This is what they put. This is called the hydraulic jack, right? Right? So when you push on the jack, the car goes up. So guys, let me ask you, when you're pressing on the jack, are you pressing on the small piston or the big piston? Are you using a small force or a big force to press the machine? Small or big? Now you are pressing, not pressing the car. You're pressing you're pulling the lever. You're pressing this thing. Are you pressing on a small or big piston? Are you pressing on a big or small piston? You're pressing on the small piston, right? Because you're using a small force. And then the big piston should be under the car. Big piston is to create a big force to lift the car. Guys, cool? Are you okay with this? Are you okay with this? So easy, right? So easy, right? So hydraulic is a very awesome machine. I can use a very small force to lift a very heavy load. How many 100 times I want? It depends on how big I make this. If I make this piston even bigger, I can lift an even heavier load. Okay? Cool? Easy, huh? Easy, huh? So guys, to make your calculation simple, sometimes we just summarize it as like this. F1A1 equals to F2A2. I just straight away sub in the force, sub in the area, sub in the area again. I just calculate my force. So my force is 500. This is the shortest way, right? I mean, you can do this also lah. You calculate the pressure first, then you put in the pressure here, and you do it again. Can, same calculation, but this is the fast way. Okay, this is the quick and the fast way. Okay, hope you guys are okay, huh? Easy stuff, huh? This is really easy stuff. There's only one calculation for this chapter, in fact. Okay, there's only one calculation. Okay, so where do we use this? Okay, let's look at application now. Where do we use this? We use this in our hydraulic jack. Like I said just now, this jack here, this jack here. But of course, this jack it's not so easy. Like, oh, I press this down, this thing will go up, as in like that. No, guys, have you seen this before? Have you guys followed your dad to the workshop before? Have you guys seen this thing before? It's not like you press it once the car goes up. No, you have to keep pressing and pressing and pressing and pressing. You have to do it like few times, and then the car will go up, 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 up. Maybe you have followed your dad to a tire shop. Okay, maybe your car has a punctured tire. Then you go to the workshop. They will they will use this thing to lift your car. Right? Maybe you have heard of it. Maybe you have seen it. I don't know. Okay, so this is how it works. This is how it works, right? So why do I need to keep pressing and pressing and pressing? This is how it works, right? So this is, you see, as we learned just now, small piston, big piston, same thing. You see, small piston, big piston. Why small piston here? Because you use small force to push. Okay, you use small force to push. Okay, so small piston, small force. Big piston, you're trying to lift a very big load. So big piston, big load. So when you press this down, the liquid will go here. Can you see a valve here? This valve will open. So the liquid will go here and press this thing up. Okay, so if you press down this thing 5 cm, this thing will lift up 5 cm. Easy. Now, next, what do I do? I need to draw this lever up, right? Because I press down, I have to draw up. But you see, here's the problem. If there's none of all these, something stupid will happen. You push down, the car goes up. You pull up, the car goes down. So if you go up, down, like that, won't the car just go up, down, up, down, up, down? You see, it looks really stupid. So what do they do? Now we have all these valves here and this tank here. Pay attention to this tank here. So what's going to happen, you see, if I press, let's say, 100 ml, okay, let's say I press 100 ml of liquid here, the 100 ml will push this load up. Now, when I draw back up, I don't want this 100 to come back. I want it to stay here. I want it to stay here. So what do? I have these two valves. This valve will close so that the 100 cannot come back. It will stay this height. Now this will open. I will draw 100 from here instead. I will draw 100 from here instead. So this thing repeats, lor. This thing repeats, lor. I draw 100 here. Now this thing is filled. Now I push another 100 here. Okay, then I draw another 100. I push another 100 here. So as I keep drawing, pushing, drawing, pushing, drawing, pushing, this place here will have more liquid. So this thing will go up, 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 up. Does it make sense? Does it make sense to you? Does it make sense to you? I push liquid here. I draw liquid from another tank. Then I push it here again. I draw from another tank. I push it again. Draw, push, draw, push, draw, push. This thing will keep going up. Right? So now what happens when I want to let this thing down? After I fix my car, I want to put the car down. Very easy. There's a release valve here. There's a release valve here. Once I open it, all the mLs, let's say you have 500 mLs here, everything will flow back to this tank. Now this thing is reset to normal level. Okay? The release valve is usually, the release valve is usually here. Can you see a stick there? When you turn it, the car will come down. That's the release valve. Usually lah. Okay, usually it's that way. Guys, do you have any question? Do you have any question? They won't ask you the exact operation in SPM. Okay, they won't ask, but it's good to know. It's good to learn. Okay, my point is, this is hydraulic. I'm using a small force to lift a very heavy load. I'm using maybe 10 kilo of force to lift a 1000 kg car. You see, I'm amplifying my force by 100 times. So this hydraulic is a very good system. It's a very good machine. We even use it in our brake. Okay, in our brake. You know your car brake, guys? You know your car brake? So same thing. You know your car has a brake pedal, right? Guys, you're allowed to drive now, I hope. You're 17 this year. After you pass your after you pass your birthday, you're 17. Now you're allowed to take your driving test. Now I'm sure you can drive already if you took your driving test. Okay, so can you see the pedal here? This is the brake pedal. Okay, this is the brake pedal. So when you step on the brake pedal, it pushes on a small piston. Right? You see, this is the main piston. Now, why small piston? Because small piston means you use a small force. You press with a small force, and then now the liquid will go to your front brake, will go to your back brake. Can you see? Big piston, big piston. So big piston, big force. Small piston, small force. You're using a small force. Big piston, big force. You're using a big force to step, to brake your car, to clamp on the wheel. Guys, you know how brake works? You know how brake works? These two brake pads, they are very rough, like your shoe sole. They will press and have friction on this plate. This plate will stop spinning. So your car brakes off, your car stops off. Right? So same thing. Small piston, small force. Big piston, big force. I'm using a small force to generate a big force to stop the spinning wheel. Right? Everything is achieved by hydraulic, by the liquid inside. Okay, by this liquid inside. And just to give you some extra info, we don't use water. Guys, for all hydraulics, we cannot use water. I mean, you might say, sir, water is a liquid, right? Why don't we use water? Because water is not very stable. Water has very low boiling point. Water has very low boiling point. Guys, hydraulic fluid, they need to get hot. They need to get hot because you see, when you are driving, you keep stepping on the brake. As you keep stepping on the brake, you are making the brake fluid, this fluid here, you are making it hotter. You're making it hotter. So as it gets hot, If you put water inside here, water will get hot and then it will boil. Water will start boiling. Water will start boiling. Once it starts to boil, you start to get air bubbles inside. Guys, I have a question here. If you have air bubbles inside your hydraulic, what's going to happen? If you have air bubbles in your hydraulic system, what's going to happen? Is it good news or bad news? No, it won't go kaboom. It won't go kaboom. Okay, you see what's going to happen? What's going to happen? You see, liquid cannot compress, right? Liquid cannot compress, right? That means if I press down, like I said just now, you press down 5 cm, 5 cm will go up here, right? All the force is transmitted to the next piston. But if you have a lot of bubbles here, so when you press on this, instead of going up here, you're wasting energy to compress the bubble. You're making the bubble smaller instead of transmitting the force up here. So what's going to happen? If you have bubbles in your braking system, when you step on the pedal, you are not sending the force to your front brake, but now instead you are squishing on the bubble. So now your brake is going to feel spongy. Your brake is going to feel spongy and how do I say this? A spongy. You know it's spongy? Spongy, your brake doesn't feel very firm. You see, when you step on a brake, you can obviously feel the brake clamp on your car wheel and it feels very firm. But if your wheel, when you step on a pedal, it goes all the way to the floor and it doesn't feel very, very confident. That means you have air in your system, right? That's why when you're changing your brake fluid, it is very important to get rid of all the air in it. Because if not, your braking system will fail and it's a very dangerous situation to be in. You don't want your braking system to have air. Okay, so this is your brake law. Hey, sir, how come front brake and rear brake different? Front brake, they will use disc brake, and rear brake, they will use drum brake. This just let you know, because the front brake should be stronger than your rear brake. Okay, the front brake should be always stronger. So this brake is like stronger. Okay, can I? So this Bernoulli's principle, this Pascal's principle is done. This Pascal's principle is done. Right, guys, do you have any question? Are you okay with the calculation? If you're okay, then we shall go to the exercise. Okay, do let me know if you have any question. Okay, guys, can you please go to page 6? You see this chapter only has 5 pages of notes. So let's go to page 6. Okay, let's look at number 1. This is the same thing. When I press this, water will squirt out equally because it's the same pressure. Pressure in a liquid is always the same. What happens when the piston is pushed inward? Okay, when you push it inward, water squirts out equally. Okay, water will squirt out equally. Next, name the principle shown. What principle is this? This is your Pascal's principle. Okay, Pascal's principle. Describe the principle you have mentioned in B. Okay, describe the Pascal principle in Z. What does Pascal principle say? So pressure exerted on an enclosed fluid is transmitted uniformly throughout the fluid. Is it transmitted uniformly? This is what I put it lah. Mine should be different. It's uniform in all direction, whatever. Okay, as long as the meaning is there. You guys okay so far? This is like more explaining than calculation. So take the correct statement for B. So pressure acts in all direction, not one. liquid cannot be compressed. It's used in hydraulic. Okay, so E we skip, not important. E we skip. All right, guys. Can I give you some homework since we have some time? Okay, I'll let you do some. Can you please do question 2? Question 3. Okay, question 2, question 3, and question 6. 2, 3, and 6. That's all. I'll give you 15 minutes. If that's enough. Right, guys? I'll give you 15 minutes. You may try this now. I'll come back with the answer later. Okay, guys? Do don't sit here and wait for the answer. Please do. Right, so I'll give you the answer in 15 minutes. See you then. All right, guys, are you done? Are you done? Can I give you the answer? I hope you are. So this question 2 is very easy. So pressure exerted on the liquid on piston A. Oh, by the way, let me write out the area first. This is 0.025. This is 0.5. Are you guys there? Are you guys still there? So pressure on piston A, P equals to F over A, which is 15 over 0.025. So what's the answer, guys? Can anyone give me the answer? I am lazy for calculator. Can anyone give me the answer here? 15 divided by 0.025, what do you get? Hello, anyone? Anyone? What's the answer here? What's the answer here? Anyone? No, don't convert to cm. Don't convert to cm, because if you convert, it's gonna be a lot of trouble. Just stick to meter, because in fact, SI unit is meter. SI unit is meter. So if they give meter is the best, you stick to meter, right? So what's the answer? What's the answer? There's no need to convert. They give you cm, you use cm. They give you meter, you use meter. So what's the answer? Jella, are you there, Jella? Did you do this? What's the answer? May I know? Hey, nobody did this. Wait, what's the answer? 600. Thank you, Shahid. Okay, 600. The unit is PA, Pascal. Or you can just stick to Newton per meter square. Also okay. 600. Okay. What about the pressure at B? Do we need to calculate this? Do we need to calculate this? If the pressure here is 600, what is the pressure here? According to Pascal's principle, pressure throughout the liquid, it's the, I just wrote it just now. You see, pressure exerted on a fluid is uniform, it's the same, right? That means if the pressure here is 600, the pressure here will also be 600. No calculations needed, right? No calculations needed. Now they want the force on piston B. So P equals to F over A. P is 600. A is 0.5. So F is 300 Newton. Right? Easy. Easy. 600 Newton is the force you are creating. You are using 15 Newton to lift 300 Newton. That's like 20 times the weight. You are lifting 20 times more. All right. So D, calculate the maximum weight of load X that can be lifted if piston B weighs 50 Newton. If this piston itself is 50, what's the weight that can be lifted? Do you understand this question? Do you understand this question? That means this whole thing is 300, right? If the piston itself, because piston itself has weight, so the piston itself is 50, what is the load here? 300 minus by 50 lah. So the answer is 250. Do you understand this? Do you understand this? The whole thing here, I can lift 300, but I have to consider this piston that I'm lifting. This piston itself is 50, so I can only lift 250 here. We have to consider the piston also. All right, so number 3, name the principle. This is your Pascal's principle. Compare the pressure at P and Q. Like I said, pressure is the same throughout. Same or similar. Like just now, 600, 600. Okay, so B, we have two systems here. System X is 50 cm to 200 cm. Okay, I'm lifting 40. System Y, 10 cm to 150 cm, I'm lifting 150. Right? So can you see this is like 4 times, this is like 15 times. Right? Obviously, Y is a better system because I can lift something heavier. Can you see? Whereas X is only 4 times. So compare the efficiency of the hydraulic system X and Y. So who is more efficient? Y is more efficient than X. Okay, Y is more efficient because it can lift more. Explain why. Because Y can lift more weight than X. Okay, I can lift more. So relationship between surface area for both. So surface area of P is smaller than Q. Obviously, because Q is bigger, P is smaller. So hydraulic jack, the one we lift our car, is one of the tools that use hydraulic system. How can a hydraulic jack make your job easier? It can increase, or you can say it can amplify. It can amplify our force applied. Okay, amplify the force to something bigger. Just like this. I push with 10, I lift 150. I'm lifting 150 times my weight, 150 times my force. Right? You guys okay? You guys okay? Very simple. Jala, are you still there, Jala? Don't fall asleep, Stay with me, I have 5 more minutes here. Okay, guys, let's go to question 6. This is the brake one. You see, small piston, small force, big piston, big force. So if you are driving a sports car, the brake is even bigger. The piston is even bigger, right? If you look at sports car, you understand. So they will talk about how many piston is the brake caliper, right? Normal car is 2 piston. Sports car is like 4 or 6 piston. Each wheel, right? You will need such a big braking force if your car is a sports car, right? Name the principle used. Again, this is Pascal. Right? One characteristic of the fluid. Okay, fluid is incompressible. Must be incompressible. Because if it is compressible, then it has bubbles, then it's not a very good liquid. So piston A has area of 7. This part is 7. 200 Newton is required to be exerted on each disc brake by B. So each brake needs to give 200 Newton. Okay, to stop the wheel spinning effectively. The average force that the driver exerts on the brake is 35. Yeah, we are stepping on the brake with 35 Newton. So determine the cross-section area for B. What is the area here? Right, very easy. F1A1 equals to F2A2. So 1 is here. F1A1 is 35 over 7. F2 is 200 over A2. So A2 is, this is 5. So A2 is 200 over 5. 40 cm square. Right, so the area here should be at least 40 to give you this force. Simple calculation, this is like one step they want everything, so you use this. You can also use this now, the one, our question 2 one. Okay, you do the pressure first, P equals to FOA, divide it out, and then you sub in to another side. Can also, but this is more time saving. So C1, why is it dangerous when air bubbles are trapped in the brake fluid? I just said it just now, because air bubbles are compressible. You can compress air bubbles. Why is water not suitable? Okay, because water has low boiling point. Right? If you have a low boiling point liquid here, this thing will easily boil and evaporate. So now you have air inside, which makes it very dangerous. Okay, so this brake fluid usually has high boiling point to really stand that that high temperature. Okay, guys, are you okay? Are you okay? So if you're okay, I'm just gonna end it here lah. Next week we will go to Bernoulli's principle, which is the last part of this chapter. There's only 2 parts of this chapter. You guys okay? Charlene, you okay? Jella, are you okay? If you're okay, it means I will call it a day lah. Okay, very easy stuff. So yeah, that's it for today. Thanks for coming. I'll see you next week. Okay, guys, take care. See you and bye bye.